So first thing, how is everybody? Just like put a reaction in chat or say something in chat, I guess. All right, so today we are doing SAT math. One sec, let me just do that. And yeah, so if you click on that link that I put in the chat, you should be able to go to a spreadsheet which has the links to all of the classes slides, including every single one of the previous ones. So if you don't have access to one of them, that should give you access to it. I recommend like perhaps like having that link somewhere handy. So if you do want to go look at slides, you don't have to try to, I guess, find the link through your history or whatnot. And you can just access it through a bookmark or something. But yeah, let's get started. So today we'll start off with data inferences. So what are data inference problems? So data inference problems require you to use a sample set of data to answer questions about a larger population. So for example, like when we want to answer questions like how many voters feel positively about a new law, or what percentage of Americans exercise regularly, it's really like impractical to ask everyone, and it would take a lot of time and effort to ask every single voter if they support the law or not. Instead, like when we have the questions about a large population, we often answer these questions by surveying a representative sample, which is like a smaller set of people whose answers can give us a good idea of how the population would answer the same questions. So how do you make generalizations about a population using sampling data? So you could estimate using sample proportions. So a random sample drawn from a population is representative of the population. With a representative sample, you can multiply the sample proportion by the population to get an estimate. So the formula is estimate equals to sample proportion times population. So what is margin of error? So a small note, so questions about margins of errors don't usually appear on the SAT, but when they do appear, the margins of error are given, and you don't need to calculate them ourselves. But you should know how to like what they are and what use they have, because you could be asked about a question that requires you to use margin of error. And yeah, so while we can make reasonable estimates using sample proportions, we can never be 100% certain that a population proportion matches the sample proportion exactly. And margins of errors lets us address the uncertainty inherent to sampling. So the margin of error is most commonly given as a percentage. When given a percentage estimate and a margin of error, we can establish a range amount around the estimate by adding or subtracting the margin of error. So for example, like the range would be estimate plus or minus margin of error. And an example of this is if a poll estimates a political candidate will likely win 51% of the popular vote with a margin of error of 2%, it actually means that the poll is reasonably sure the candidate will actually win 51% plus or minus 2% of the popular vote. So anywhere between 49% and 53%. The larger sample size is, the smaller the margin of error will be. Think about it this way. So if you want to make an estimate about a population of 1 million people, we would get a more accurate result if we ask a random sample of 5,000 people versus a random sample of 50 people. So for the person who was asking, when's the last day for this class? So this is the 16th 16th class, and we have 20 classes overall. I'm not sure what the exact date would be. However, after this, we have 4 more classes, which is like 4 more weeks, I guess. So really just a month. And if nothing does come up in those 4 weeks, then I have to postpone or extend this. But we should be done in another month. So here is, I guess, a practice problem, which you guys can do first, and then I'll do it right after. I'll give you guys 2 minutes to do this. Again, just put your answer in the chat after you get it. Again, just put your answer in the chat after you finish. And of course, you won't get an exact number. However, round to, I guess, the nearest number to get your answer. or no, not your nearest number. Remember, a household, you can't have half a household. You can just like total number of households, I guess. I'll give you guys another minute to do this. So most of you seem to have the right answer. However, there's some rounding issues. In the real SAT, you'd have multiple choice with I guess a number which is closest to it given. So the people who did get it off by 1 or 2, because of rounding, you would get this right in the SAT because they would give you an answer choice which is there, and probably another couple of answer choices that are far away from it. But yeah, so I will do this problem now. So we know that the sample proportion is, let me just write this down, sample proportion is equal to 14.8 percent, which is when converted to decimals, I guess, of 0.148, and the population is equal to 59,317, and the estimate would be 0.148 times 59,317 to get a roughly 8,779. And the reason for this is, if we go back a couple slides, I gave you the formula to get it, as it says right there. The estimate equals the sample proportion times population. So in this case, you should get 8,779. Again, if you got 8,778, that's probably a rounding thing, and the SAT wouldn't give you two answers, 8,778 and the 8,779. It would just give you one multiple choice that's one of those two. All right. So center, spread, and shape of distributions. So what are center, spread, and shape of distributions problems? So center, spread, and shape of distributions are also known as summary statistics, or just statistics for short, and they concisely describe data sets. So center describes like the typical value in a data set. The typical value in the data set, SAT covers like 3 measures of center, which is mean, median, and sometimes mode. So for the people who are asking for the formula for the previous thing, the formula is estimate equals to sample proportion times population. Tell me once you finish writing it down so I can move back to where we were. All right. But yeah, so so the SAT covers 3 measures of center, which are mean, median, and sometimes mode. And the spread describes a variation of the data. So 2 measures of spread are range and standard deviation. So how do you find the mean, median, and mode? So for mean, the mean is the average value of a data set, which is the formula for it is mean equals the sum of values divided by number of values. So say you have a data set 5, 1, 3. The mean of this would be 5 plus 1 plus 3 over 3, because there's 3 things. 1, 2, 3, which in this case is 9 over 3. And that's just 3. That is your mean. Median is the middle value when the data is ordered from least to greatest. So if you have the same thing, 5, 1, 3, you'd order it least to greatest. So 3, 1, 5. 3 is the median. And if you say you have 1, 3, 4, 5, then the median is when there's the number of values are even, the median would be 3 plus 4 divided by 2. which is 3.5. So, and then mode. Mode is the value that appears most frequently in a data set. And a data set can have no mode if no value appears more than any other. And a data set can also have more than one mode. So in this case, there is no mode because all of them happen equally, I guess. In this data set, 1, 3, 3, 5, 3 is the mode. In this data set, 1, 1, 3, 3, 5, 9, 1 and 3 is the data are the modes, and so on. So how do you find the range and standard deviation? So on the SAT, we need to know how to find the range of a data set. And while we won't be asked to calculate the standard deviation, we do need to have a sense of the relative standard deviation of two data sets. So the range. The range measures the total spread of the data, and it's the difference between the maximum and minimum values. So the formula for it is range equals to maximum minus minimum value. And a larger range also indicates a greater spread in the data. So again, if you have the data set 1, 3, 5, the range is 5 minus 1 because 5 is the greatest and 1 is the least. So the range is 4. Standard deviation. So standard deviation measures the typical spread from the mean. It's like the average distance between the mean and the value in the data set. And larger standard deviations indicate greater spread in the data. So in this case, for the data set 1, 3, and 5, the mean, which is 3, has a standard deviation of 2, because this way, if you go 2, you get 1. If you go this way, you get 5. And yeah, larger standard deviations indicate greater spread in the data. So how do outliers affect summary statistics? So the effects of outliers. An outlier is a value that in a data set that significantly differs from other values. And the inclusion of outliers in data sets can greatly skew their summary statistics, which is why outliers are usually removed from data sets, even if you did somehow get them. And the effects on range and standard deviation. So the inclusion of outliers increases the spread of data, leading to larger ranges and standard deviations. Conversely, removing outliers decreases the spread of data, leading to smaller ranges and standard deviation. So an example of this would be if you have the, I guess, data set 1, 3, 4, 5, and 100, the mean is greater than what you would have if it was 1, 3, 4, and 5, because the mean of this would be a lot higher since you have to add each of these divided by 5. It's 5 and then, yeah, just 5. The mean is a lot higher for this one versus the mean for this one. And same with the range. For the range for this one would be 99 because 100 minus 1. And the range for this one is only 4. And because of this outlier, the range is a lot higher than it should be. And again, like I said before, the standard deviation is also completely changed because the mean is really far away from the rest of the data points. So the standard deviation is also really high. So the effects on the mean. An outlier can significantly skew the mean of a data. For example, consider the data sets 3, 5, 7, 7, 10, 100. The 100 is an outlier and is significantly larger than the other values in the data set. And if you include the 100, the mean of the data set is 22. And note the mean, the mean 22 is greater than 5 of the 6 values in the data set. But if you remove the 100, however, the mean of the remaining values is 6, which is a lot more reasonable because it's greater than 2 of them and less than 3. The removal of an outlier is guaranteed to change the mean. If a very large outlier is removed, the mean of the remaining values will decrease. And if a very small outlier is removed, the mean of the remaining values will increase. So how do outliers affect summary statistics continued? So the effects on the median. So the median of the data set 3, 5, 7, 10, and 100 is 7. If the outlier on 100 is removed from the data, the median will still be 7. And because the median is based on the middle values of a data set, the outlier does not affect the median of a data set as strongly as it affects the mean. As such, the removal of an outlier can still change the median, but that change is not guaranteed. If a very large outlier is removed, the median will either decrease or remain the same. And if a very small outlier is removed, the median of the remaining values will either increase or remain the same. So how do you use the mean to calculate a missing value? If we know the mean of the data set and the number of values, We can calculate a missing value in the data set by calculating the sum of values by multiplying the mean by the number of values and subtracting all known values from a data set. So say we have the data set again. Oh, oops. We have the data set 1, x, 5, and we know the mean is 3. So you multiply the mean by the number of things in the data set, so times 3 equals 9, and then we subtract the stuff that we do know, so -5 minus 1 to get 3, and we know x is 3 then. So any questions about what I just said? No? All right. So center, spread, and shape of distributions. Practice problems. I'll give you guys 2 minutes to do this. And yeah. Okay, just put your answer in the chat after you finish, so I know if you guys got it right or wrong. And if you don't know how to solve this question, just put in the chat so I know that I should solve this question for you guys instead of just waiting for people to solve it when people just don't know how to solve it, I guess. Right, it looks like most of you have got this right. Do you guys still want me to explain it, or do you guys just want to move on? All right. So the answer is not A, because when you check the range of test scores, Amara's range of test scores is 5, because you have the highest test score, which is 90, and the lowest test score, which is 93. So the range of her test scores is 5, while Lance's test scores range from 100 to 88, which is 12. And Amara's does not have a high range, greater range of test scores than Lance does. So it's not A. B, Amara has a greater standard deviation in her test scores than Lance does. So Amara's test scores are more cluttered. They're all between like 93 to 98, while Lance's test scores are like spread apart. They're somewhat evenly spread apart between 100 and 88. Well, not really, no, because the 88's there. So Amara's has less standard deviation because the difference between all of our test scores are a lot less a lot more cluttered than Lance's test scores. They're all more like together versus Lance's test scores, which differ quite a bit. And then C, so if we add up the means, so you have 98 plus 95 plus 94 plus 93 plus 95 divided by 5. You should get like 95 as that. And 96 plus 95 plus 100 plus 88 plus 96 over 5. And you should get 95 again. So this is correct. And C is our answer. Do you guys want me to show you why it's not D as well? Or should we just move on now that we got the answer? All right. 1 second. All right, so data collection and conclusion. What are data collection and conclusion problems? So we routinely conduct research to answer questions such as like, how many residents are in new favor of the law, or is the new medical treatment effective? And while research results can give us powerful insights, we also have to carefully consider how the research is conducted, which in turn affects what conclusions are drawn. So for example, if a survey was given to individuals of one ethnicity, then the results of the survey are not representative of individuals for other ethnicities. And if a medical treatment is effective when tested on mice, we can't conclude that the treatment is just as effective on humans without additional testing. And we won't be required to like perform calculations in data collection and conclusion problems. Instead, we'll be asked to like read really, like, maybe not really, but like fairly lengthy descriptions, and to make logical observations or draw like valid conclusions. So sampling methods and their implications. So ideally, a sampling method provides information about a population without having to survey the entire group. To make valid conclusions about a population, we need a sample that recreates the characteristics of an entire population on a smaller scale. And a good sample size is representative and random. Representative means the sample size includes only members of the population being studied, and random means that every member of the population being studied has an equal chance to be selected for the sample. Bad sampling methods include those that gather data from outside the population being studied, gather data that overrepresents or underrepresents a subgroup of the population, not random, and and drawing conclusions from study results. So sample surveys, we can draw conclusions about only the population from which the random sample is selected, and controlled experiments. To understand the conclusions we draw from controlled experiments, we must first understand the difference between correlation and causation. So causation means there's a relationship or pattern between the two values of two variables. And causation means that one event causes another event to occur. So you may have learned about controlled experiments and the scientific method in more detail in like your science classes. And again, this is in the SAT math section. However, like you're given problems that require you to know, I guess, like some of the scientific method, because they just ask questions close to it. They give you information for it. And like the key takeaway is that a control group is needed to establish a causal relationship. So here is a question. Give you guys 2 minutes to do it. Again, just put your answer in the chat after you finish. All right, I'll give you guys another minute to do it. Though it looks like most of you have got it right. All right, so it looks like everyone who's answered it has got it right. Do you guys want me to do this problem, or you guys want to move on? Or no, wait, it does look like some of you have got it wrong. One sec. I didn't see the people who got it wrong. So the answer to this question is C. And the reason for that is, one sec. The answer to this is C, if that loads. What? Why isn't this loading? Okay. The answer to this is C. And the reason that for that is all of the participants in the survey are teenagers between the ages of 16 and 17. Between the ages of 16 and 17 in the US. And therefore, the results of the survey most likely reflect the opinions of all 16 and 17-year-olds in the US, because the sample has been taken from a certain group of people, which are the 16 and 17-year-olds. Any questions why it's C and not B, like some of you chose? No? All right. Any questions about what we did so far? About anything, I guess, really? No? All right, practice problems time. I will give you guys 2 minutes to do this problem. Again, just put your answer in the chat after you finish doing it. Right, I'll give you guys another 30 seconds for the people who still haven't solved it yet. All right, 30 seconds. I think I already said that. All right, so it looks like a couple of you have got this question wrong, have answered this question wrong. And one sec, my thing isn't working again. Just check why. Why is this working? All right, so the way you solve this question, I think it's working now. Is this working? All right. So this way you solve this is, remember the formula, estimate equals to sample proportion times population. So you know the sample proportion is 482 people out of 600. And the total population is 90,010. And you multiply these two together to get 15,512 as your answer. Any questions why it's not A? Would anyone like to explain why they got A? For the people who did get A? Just raise your hand so I know, I guess. So I can unmute you. Yes, for these types of problems, you can use a calculator because there's no way they expect you to know how to multiply 482 over 600 times 19,310. But yeah, the answer for this one is C. Here's another problem. I'll give you guys 2 minutes to do this one. So I would never recommend you just guess, because guessing inherently can lead you to get the problem wrong. Because if you just guess, then you don't know what the answer is and you're just guessing, really. I would never recommend guessing unless you genuinely have no clue what the question is asking and you have no time left to try to puzzle it out. That's the only time I'd ever recommend guessing your answer. All right, here is the next problem, I believe. Yeah. I'll give you guys another 30 seconds or another minute so you guys can get it. Another 30 seconds. All right, so it looks like everybody who's answered this question has got it right. Do you guys want me to go over this or just move on to the next question? And just so I don't have to keep answering, keep asking that question every time we finish the problem. If you guys don't know how to do a problem, just say, please explain in the chat beforehand. So I do know if people want me to explain it. And yeah, it looks like some people do want me to explain it. So Anna is like, so let me just look at this real quick. So Anna sampled a random sample of members from a large gym, but how often they visit the gym. And she estimated that 74% of gym members go to the gym at least once a week with a margin of error of 3. And which of the following is the most appropriate conclusion about all the members of the gym based on the given estimate and margin of error? So remember, the way you do it with margin of error is it's your range. The formula is range equals to estimate plus or minus margin of error In this case, it's 74 plus or minus 3, and that's 71% to 74%. And the only one that does that is C. Varun, do you understand why it's C? All right. Here's another problem. I'll give you guys 2 minutes to do it. I'll give you guys another 30 seconds. I'm seeing a lot of different answers. But it looks like most of you have got this right. Do you guys want another couple of seconds, or should I just do the problem now? For the people who still haven't answered it yet. It looks like some people still need more time. All right, 1 second. One second. All right. So for this question, you're given that, so there's 50 seniors at a particular high school who are selected for a survey, and 21 of them report riding their bikes to school at least once a week. And there's like 300 school seniors at this high school. What is like a number, reasonable estimate of the total number of seniors who ride their bikes to school at least once a week? So first thing is you have your sample proportion 21 over 50, because 21 over 50 of them have said that they do, and your population, so sample prop, and your population, which is 300. So your estimate, remember, estimate is sample prop times population, which in this case is 126. So for the people who got it wrong, would you like to explain why, so I can tell you what you did wrong? Or because I saw a couple of other answers other than 126 for the people who did answer it. So also, Bhavana, what you did wrong is you did your total over your sample. So you did 50 over 21 versus 21 over 50. You just put your proportion backwards. But yes, that would have worked if, actually, no, wait. You also did the 300 over x wrong. It's x over 300 equals to 21 over 50. All right, does no one else want to, does anyone else have any questions about why it's 126 and not some of the other answers that were given, I guess? Yeah, so yeah, Karen, you could write the equation as, so you could do it my way, or you could write the equation as 21 over 50 equals to x over 300, because in essence, that's the same thing, because you're multiplying 300 on this side to 300 on this side. And that is literally just x estimate equals to sample prop times per population. But yes, this is a reasonable way of doing this. Wait, did I? I might have put the answer wrong for this question. One sec. Okay, looks like I put the answer wrong for this one. This is 126. I'm guessing the next one I flipped it then. Yeah, no. There. So yeah, I guess people were saying that you could, I guess technically you could do 121 times 6, because 300 is 6 times as much as 50. And you don't need to do the butterfly method, because remember, what you're doing is you're trying to get rid of the 300 on this side, trying to get this over here. So you can just multiply 300 on both sides. So you don't need a butterfly method there. It's just 300 times 21 over 50. And then I guess if you want to, I'll make it. Yeah. All right. Any other questions for this slide, I guess? No? All right. Move on. Here's another question. I'll give you guys 2 minutes to do this. I'll give you guys 2 minutes to do this. Just put your answer in the chat, or if you don't know how to solve it, just say I don't know how to solve it, so I know that people want me to do it. So it looks like most of you have a pretty good answer. However, I feel like some of you are putting your answers in wrong for some of these. Remember, the second one is not asking for a proportion, or wait, is it? One second, let me just double check. 1 second. Yeah, the second one isn't asking for proportion. It's just asking for a number. But yeah, so some of you were answering the second question in proportions, and that is not correct in this case. Yeah, it's asking for a plain old number. All right. So do you guys need more time, or do people want me to explain it for the people who haven't done it yet? All right. So for this problem, for part A, the way we do this, where did this go? 1 second. I dropped my pen that I used to do this somewhere. All right. So the way we do this is you have, so an inspector examined a random sample of 500 bars of dark chocolate at the Nom Nom chocolate factory and found 2 of the bars to be defective. The factory produces 6,000 bars of dark chocolate a week. So the sample proportion of the number of defective bars to the total number of bars is a fraction. So you know that 2 out of 500 are defective. 2 out of every 500 are defective. And so that means that so 2 out of every 500 are defective. This is that is A. And to get B, or number 2, or whatever, you do 2 over 500 times 60,000, because remember the formula is estimate equals to sample prop times population, which is number of chocolate bars per day. Population. So this one would be 240, and this is the answer to this one is 2 over 500. Any questions? Also, I saw some people giving 240. Wait, let me just double check what they said. So people were saying stuff like 240 over 60,000 and stuff like that. What it's asking for is the sample proportion, and we're given a sample proportion of 500 bars overall, of which 2 are defective. So it'd be 2 over 500 versus 240 over 60,000. So any questions about this class? about this problem? No? All right, let's move on. Give you guys 2 minutes to do this one. So I see a couple of answers. It seems like some of you aren't reading the problem correctly. Again, just read the problem carefully, or even if you think you got it right, just read it again to make sure. All right. So I'd say roughly half of you got this right. The other half got it wrong. All right. So do you guys want me to do it now, or do you guys want another, I guess, another minute to retry doing this if you think you got it wrong? Again, just put it in the chat if you want more time, or I could do it right now. All right. So when you order the yields from lowest to highest, so you have what? 25 that are between 40 to 45. All right. You have 70, I believe. I cannot see that. Yeah, 70 that are between 45 to 50. And you have, I believe, what is that? 55 from 50 to 55. That is 20 from 55 to 60, and 5 from 60 to 65. So overall, when you add up all the numbers of stuff, so this one, this one, this one, and this one, so 25 plus 25, 50, plus 20, plus 70, plus 55. So 105 plus 90. So you have 195. And you want to get, or wait, did I add these up right? One sec. You have 25 right here, 55. Where did this 20 come from? 45 to 50, you have 55. Okay, so this is bad. So I did something wrong here. One sec. Let me just erase the stuff that. So All right. Let me just recount because I can't count. So 40 to 45 is right here, which is 25. 25. And then 45 to 50 is at 70. And then 55, 50 to 55, 55. I'm just gonna make this sure I know this is a 7 because there. This is 20. And this is 5. So 50 plus 55 plus 70 plus 20. So you have 105 plus 90, so 95, 195. And then you want the median, so you want it divided by 2, basically. So it's like what, 87.5. So let's say 88. And when you do count it over, so you have 25 here, so subtract 25. So you have 63 left, and it's between 45 and 50 because the 63, when you go, so the median, so, okay, now before we do anything, it's asking for the median yield. And the median yield means the middle number. So, and if there's 195 total, I guess, yields, and the median of that is 88, you want the 88th yield from least to greatest. And the 88th yield is between 45 to 50, and therefore the answer must be B and not C. Does everyone understand why it's B and not C? So the yields, so you have yields. Okay, so the question is asking for the median yield of the acres. So each acre gives a certain yield, all right? And each yield has a certain number of acres that give that yield. So, and we're trying to find what is the median yield for the acres. I'm not sure if I'm explaining this very well. Could you come on I guess Mike and explain what you don't understand, so I can explain it that, I guess. Just raise your hand so I know I can get to you fast. So the yield for 45 to 50 is equal to 20 because there's 20, 45 to 50. That's not 20. It's 70. 45 to 50 is 70. So you know that do you want to just come on mic so you don't have to type in that much? All right. Just raise your hand so I can unmute you.
How did you out that the number? So after like finding out that it's 70, what's the next step?
So the next thing you do is you know the numbers for each of these, right?
Yeah.
You add them up to get like the total number of yields. Like number of acres that are used, I guess, really.
Yeah.
All right. And you divide by 2 because you're trying to get the median, the middle value.
Okay.
And now you want to go from least to greatest or greatest to least doesn't really matter. And you want to go 88 steps. So pretend on the first one you go 25 steps. You have 63 steps left. 70 is greater than 63. So somewhere in 45 to 50 is your answer.
Oh, okay.
And that's how you get the answer B.
All right. Thank you.
All right. Does anyone else have a question? Could you just lower your hand if you don't have another question? That would be nice. All right. Does no one else have a question? All right. Here's another question. I'll give you guys 2 minutes to do this one. Again, just put your answer in the chat after you get it. Again, just put your answer in the chat after you get it, or say I don't know. So, or could you please explain it or whatnot, so I know that you don't know how to solve it and you want me to explain it. And I don't just keep waiting for answers that wouldn't come since you don't know how to solve it. All right, does anyone need more time? Just put it in the chat if you need more time, or I will start solving this problem now. All right, so the minimum value of a data set containing of 15 positive integers is 29. A new data set consisting of 16 positive integers is created by including 22 in the original data set. Which of the following must be 7 greater than the new data set and for the original data set? So first thing we can say is A can't be there because we don't know what the mean is. There's no way to calculate the mean. B is not the answer because the new data set must be 7 greater than the, because like the median of the new data set has to be 7 greater than the median of the old data set. But like because the median of the original data set can't be determined, we can't say B because we don't know what the median of the original data set is. C. So the formula for range is maximum minus minimum, as we know. Range equals to max minus min. No, that didn't pair. And one sec. And like the minimum value of the new data set is 29 minus 22. Minus 22. Because the minimum value for the old one and the new minimum value is 22 equals to 7. So that alone should give it to you because 22 is lower than 29 and both the data sets are the same other than the fact that 22 is included. So that itself gives you that the answer is C. And yeah. Any questions why it's C and not one of the other three? No? All right. So the reason it's not D is because we can't tell what the standard deviation of we can't verify that the fact that the standard deviation of the new data set is 7 greater than the standard deviation of the original data set because like we don't know what the standard deviation of the original data set is. There's no way to figure out what the standard deviation is for the first data set. Do you understand, Siri? All right. Here's another question. You guys have 2 minutes to do it. Again, just put your answer in the chat after you finish, so I know when people are done. And if you don't know how to do it, just say, could you please explain? So I don't wait for people to keep solving it. I'll give you guys another minute for people who are in the middle of solving it to solve it, and then I'll do it because there are people who said they want me to explain this. All right, you guys got another 30 seconds to do this, and then I will do it. Also, Karen, did you mistype that? Because I don't think 12 is the answer. I'm hoping that at least because it drove a lot more than 12 on average. And the reason for that is it says he drove on average at least 40 miles per day for 6 days. And you put the longest distance that he drove in 12 as 12. So I don't think you read the problem correctly if that's what you got. All right, so it seems I was on mute. Okay, yeah, sorry about that. So we know that last week, George drove 52 miles on average per day. So 52 times 7, you get 364. And we also know that he drove 40 miles on average per day for the last 6 days. So that's 240. And to get the longest distance George drove in a single day last week, you have to subtract 364 minus 240 to get 124. Because we want to get the average overall subtracted by like whatever we got, not kind of the longest day. And that's how you get the longest day. So 124. Any questions? No? All right, I'll give you guys 2 minutes to do the next one. Again, just put your answer in the chat after you get it. And if you don't, just say you don't get it. I see two different answers that have popped up. Most of you have got it right though. Some of you have not. Yeah. Do you guys want another minute to do this, or do you guys want me to explain? All right. So for this question, we want so a study was done on the lengths of frogs in a pond. A random sample of frogs were caught and tagged in order to ensure that none were measured more than once. The sample contained 50 American bullfrogs, of which 40 were shorter than 7 inches. Which of the following conclusions were best supported by the sample data? So what we can say is they have a sample of 50 bullfrogs. And since 40% of them are shorter than 7 inches, we can conclude that 40% of American bullfrogs are in the pond or shorter than 7 inches, because we have a sample of 50 American bullfrogs from the pond. And therefore, we can conclude that 40% of all of them are less than 7 inches, because 40% of the 50 were less than 7 inches. Any questions? Or do you guys want me to explain why it's not a specific answer choice? And so I'll explain the ones that other people have gotten. So it's not B, because only American bullfrogs, we were talking about American bullfrogs, and only 40% of the American bullfrogs were less than 7 inches. So we can't say all frogs in the pond are shorter than 7 inches. And for C, the results don't give us any information on the average length of American bullfrogs or all frogs in the pond. So you can't say this. As for D, the sample contained 50 American bullfrogs, and of which 40 are shorter than 7 inches, as I said before. And the largest population can only be I guess, estimated is the American bullfrogs and not all frogs. So it can't be D either. Therefore, it is A. Any questions about why it's A? No? All right. Next question. Insomnia, for people who don't know, is a sleeping condition where you just can't fall asleep. Just in case you guys don't know. I'll give you guys 2 minutes to do this one. Again, just put your answer in the chat after you finish, so I know if you guys finished or not. Or if you don't understand how to do it, just say, please explain. So I know that people just don't know how to do it. All right, it looks like most of you have got this right. Do you guys want me to explain why? It's the answer is C. But yeah, the answer is C. And it seems like almost all of you have got it right. You guys want an explanation why? Or just move on? So does anyone need an explanation? Just say it in the chat, or else we can move on to the next question. All right. Doesn't look like anyone needs an explanation for this one, but all right. So for the next three problems, I put these in while you guys were working, so I don't have the answers in the slides. However, I do know how to solve these, so I will explain to you guys after you guys do them. I'll give you guys 2 minutes to do this one. Again, just put your answer in the chat after you get it so that I know if people are done or not. All right, so looks like most of you have got this right, with some people, I guess, getting confused. The answer to this question is C. And the reason for that is we know that removing one high number from the set is not going to affect the median, because there's 3 number 12s, or 4 number 12s actually. So the median's not going to shift, since it's just going to stay at 12. And the mean will shift if you don't include the 24th measurement. However, there's 20 other, I guess, measurements in the data set, so they will anchor it and it won't shift that much. In case of the range though, you're shifting from 24 minus 8 to 16 minus 8, so it's a big jump, and therefore range is the answer. Any questions? No? All right. I'll give you guys a minute to do this one, and then we'll spend a minute on the last one, and then that's it for class today. Do you guys have an answer? Or do you guys just want me to do it if you guys don't know how to do it? All right, I'll give you guys another 30 seconds for you to do this. All right. So for this question, the answer is B. And the way you get this is, one sec, I gotta move this. Whoop. The answer is B. So the way you get this is you first have to find the median. And if you write these all out, 19.5, 21.9, 25.9, 27.9, 30.1, 35.5, 36.4. And from this, we get that our median value is 27.9. But we're not done here. Then we have to calculate the difference between the median and the median for all 50 states, which is 26.95. So when you subtract these two, you get 0.95. And that is your answer. So B. Does anyone have any questions? No? All right. So we're going to skip the last question because we don't have time. However, I will put the answer in for next one, which should appear, but didn't. But I'll put in the question. I'll put in the answer for this one later. You guys can look over it since you guys have the links to the slides. So yeah, just like for next class, to search up more information about the ACT. I forgot to change this part. What you guys have to do for next class is not that. Instead, next class, you guys need to know we're going to be doing we're going to be doing evaluation of models, inferences, and experimental data results. And yeah, that's it, really. See you guys next week. If you have any questions, I'll be happy to answer them. We still have another 4 classes left. All right, do you guys have any other questions? Other than that, that should be it for today. Have a nice week. And for the people in the US, a long weekend as well.